So today's lesson is going to be about increasing, decreasing, and constant intervals. This would be something that you'd want to watch after you've watched the domain and range lesson. The idea here is if you've watched the domain range lesson, you know domain specifically is basically we are trying to figure out how far left a graph goes and how far right a graph goes. Today what we're going to be doing is basically taking that domain and chopping it up into parts, aka intervals, and deciding which parts of the graph are increasing, which parts are decreasing, and which parts are constant. When we say increasing, decreasing, constant, basically we're saying up, down, or flatlining. Meaning an example of something increasing would be something that is going up from left to right. An example of something decreasing would be going down from left to right. And something being constant would be just a flat line. So that's what we're looking for on these graphs. Now along with that, there's a couple of things about this that I think make this easier than the domain. First off, you will only ever use parentheses to write your intervals. Reasoning behind that would be when we were choosing between a parentheses or a bracket with the domain, we were looking at the individual dots, right? We were trying to figure out if we had an open or closed dot. Well, a single dot is not increasing, it's not decreasing, it's also not constant. It's just a point. You need to be able to compare between 2 points to have increases, decreases, or just flat lines. And so because of that, we're not really interested in the points themselves, we're interested in what's happening in between them. Meaning we're never going to use brackets because we're not using the actual points. You will always use parentheses. Second, we are always going to use x coordinates to write our intervals. Reason for that being, we just said that the term increasing means upward movement. The term decreasing means downward movement. Constant means there's just no up and down movement. So I don't want to state that information with y values, or I would just be restating the same information, right? If I say it's increasing, then of course the y values are going to go up. We don't need to show that. What we want to show is how much distance side to side, how much of the graph from side to side is increasing, how much of the graph side to side is decreasing, so on and so forth. Okay? And then, since we are breaking up the domain, wherever one interval ends, the next one should begin. But that's kind of self-explanatory, I think. So, for an example, let's take a look at this graph here. Okay, basically I think the easiest way to decide where to start would be to think of it as if you're doing a domain, where you want to see how far left the graph goes, and that's where we want to start our first interval. Well, the leftmost point of the graph, I would say, is right here at -5, 0. So I'm going to start my first interval at -5, because remember we're using x values only. Now, the question is, does the graph begin by increasing or decreasing? Well, if I'm reading left to right, it certainly looks like the graph is increasing as it is trending upwards. So I would label this as an increasing interval. Now all I need to do is decide where it stops increasing. Well, it's going up, 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 up. Looks like it stops going up right here at 0, 4. With an x coordinate of 0, that means I'd end my interval at 0. After that, it looks like it starts to decrease, starts to head down from 0. So I would have a decreasing interval starting at 0, where I ended the last interval is where I start this one. And it decreases all the way down till the end of the graph, which is at the x-coordinate 3. That's all you'd have to do to write your increasing, decreasing intervals for this graph. Let's take a look at one that's a little bit more involved. We've got a little bit more going on with this one. I'd still want to start with the leftmost point of the graph, which in this case would be over here at -4, 4. So I'm going to start with an x value of -4. And then if I look at this, I can see that it is starting to decrease to begin the graph. So I'm going to start off with a decreasing interval. I want to label it that way. And I just need to figure out where that interval is going to end. Which if we trace along here, looks like it ends right here at this point of 0, -1. So x value being 0 means that's where I would end the interval at. So my next interval should start where my last one ended, meaning since this decreasing interval ended at 0, I should be starting my next interval at 0. And then looking at what the graph does after that. Well, after 0, looks like the graph starts to flatline. right? We can see it flatline along here. And so if it's just a flat line, then that would make this a constant interval. We refer to it as a constant interval when there is no movement up or down. So it keeps going flat, keeps being constant until it looks like the x value of 6. So we'll end our constant interval at 6. That means our next interval is going to start at 6, and we'll see what it does from there. Well, looks like we are increasing after 6. We can see it heading up, and it keeps on increasing until the end of the graph, which, by the coordinate point there, looks like our graph ends at the x-coordinate of 8. So we simply label that an increasing interval, and we've got our answer.